We're going to have a look at solubility of ionic compounds in water. So I want you to consider two reactions that are shown. Potassium hydroxide plus iron 3 nitrate on the top, and then potassium chloride plus iron 3 nitrate on the bottom. So if you dig all the way back in your memory to grade 10 and you look at double replacement reactions and predicting products, you could come away with these balanced equations. The new wrinkle we're going to throw in is that we're going to say that the reaction on the top works and occurs and the reaction on the bottom doesn't. So now we're going to have a look at why that is. So in order to do this, we're going to need to introduce a new tool for you, which is the solubility table shown here. So when an ionic compound dissolves in water, we say it dissociates into its constituent ions. That means it splits into the positive and negative ions. If you examine the products as written in a balanced reaction, you can then compare that to the solubility table to determine whether or not the products will be soluble in water. So in this case, I work through my solubility table. I find potassium nitrate and iron 3 chloride, and I realize that both of the products are soluble in water. This is why we would say that no reaction occurs. If I sketch this out in a cartoon fashion, I can say that here we'll draw both reactant solutions, and we'll draw a product solution. So I can represent the potassium chloride, so I'll put 3 potassium chloride pairings in. So this is what we mean when we say dissociates. When KCl goes into water, it splits into K plus ions and Cl minus ions. Iron nitrate does the same thing. So I would end up with a solution with a ratio of 3 nitrates to 1 iron 3 plus. If I combine both of those solutions, though, all I end up with is a solution that's double the volume that it originally was, assuming they were equal volume, and I have one that has all of the ions in it now. So this is why we would say that there's no visible reaction that has occurred, because there's no net product that comes out of this. It's simply a solution that has all of the original ions in it. If we now examine something different, we look at the other one that at the beginning of this video we said did occur, we can sketch out 2 reacting vessels. So I can represent the 3 potassium hydroxides along with the iron 3 nitrate. Okay, so I can sketch all of those, and I will end up with 2 distinct solutions that have the ionic compounds have been separated into their constituent ions. Again, this process is known as dissociation, and this is what happens every time an ionic compound is dissolved in water. So if I represent the second solution, iron 3 plus and 3 nitrates, I'm then going to transfer this over, and we're going to begin to look at what happens. So let's say we combine the 2 of them, and I'm going to almost draw an intermediate step here so that I can represent the combination of all of the ions. But again, what I'm really going to be doing is I'm going to be looking at the solubility table to see if any of the combination of product ions results in an ionic compound that is not soluble in water. So we'll read that off the solubility table. So if I put all my ions in here, I have all of my irons, all of my nitrates, all my potassium, and all of my hydroxide. I'm then able to go examine the solubility table. So I'm going to find the combination of potassium and nitrate. So potassium nitrate, we find soluble. Then if I go and I look for the combination of iron 3 plus and the hydroxide ion, this is going to result in a symbol that we've not run into yet. So this we're going to find is insoluble. What this means is that I should see a precipitate form. I should see a solid form after the combination of these 2 reactant solutions. Okay, so what I should see is an iron 3 hydroxide precipitate, because the combination of the iron 3 ions and the hydroxide results in an insoluble substance. So again, to represent that in the cartoon fashion, right, I would actually end up saying the final product here is a solution of potassium and nitrate ions, and there would be an insoluble solid at the bottom of this beaker, if you will, and that solid is going to be iron 3 hydroxide. So in this case, and in the case where in any double replacement reaction where a solid is formed, this also applies to if a gas is formed, that we say the reaction occurs because we can visually observe a chemical reaction. Think back to those markers of how you knew a chemical reaction or chemical change had occurred, one of which was a gas formed or a solid produced, a precipitate from a reaction. So if you can tell a reaction has occurred, we would say that this double replacement reaction does in fact proceed. You would go back, put your state symbols into your equation. Okay, so KNO3 is aqueous, the ions remain dissolved in water. Iron 3 hydroxide is a solid because it is the precipitate. So we can summarize this by saying in order for any double replacement reaction to occur, one of the products must leave solution.